Hello, and today's purpose of the day is I can use the special triangles rules to find missing side lengths. Please take a moment and complete the warm-up. Solve the triangle for all the missing parts, including the angles and the side measures. So I'm going to label all the missing things that I need to solve. I need to solve for the angle here, and I also need to solve for side X and side Z. So let's go ahead and get started. I'll first start by solving for the missing angle. So I know 180 minus 39 and 90 degrees will leave me with 51 degrees here. And then I will solve for, let's do side X. So I know if I am given 39 degrees, I know the adjacent side right here and the hypotenuse of 7. So adjacent and hypotenuse go with cosine. So cos of 39 equals adjacent over hypotenuse. Solve for x, so multiply by 7. So 7 cos 39 equals x. And rounded to the nearest tenth for a side length will be 5.44. So just another little rounding tip. I'm going to look at if I want to round to the tenths, the digit right after that. And then I will say, will the 4 round the 4 up? Nope, it'll stay where it's at. So x equals 5.4. And then now I'll solve for side Z. So this side right here. So if I know 39 degrees, this is the opposite side and hypotenuse. So opposite and hypotenuse go with sine of 39 equals opposite over hypotenuse. Multiply by 7. So 7 sine 39 would equal 4.4. And these are all the missing pieces of the triangle. So let's get a little bit of practice on indirect measurement. You went through this in 7th grade, but let's review it. Find the height of the lighthouse right here. So we're going to need to set up a ratio or a proportion. So I know the height of this person here is 3 feet to its shadow, which is 4 feet, and that's going to be equal to the height of the lighthouse to the shadow of the lighthouse. So 12 plus 4 is 16, because that's all the shadow. So again, we compared the person and the shadow to the lighthouse's height and the lighthouse's shadow. So now I can just use cross multiplication and solve. And 3 times 16 is 48 equals 4h. Divide by 4. So h here equals 12 feet for the height of the lighthouse. So we are going to look at some special triangles rules for 45, 45, 90 degree triangles and 30, 60, 90 degree triangles. So first we're going to start with the 45, 45, 90 degree triangles. So we want to use the Pythagorean theorem and find the missing side lengths of all 3 of these triangles. And you're going to see a pattern evolve. So let's look here at the first triangle. If I am going to use the Pythagorean theorem, I need to solve for C, which would be the hypotenuse. If you look right here, that's where I'm at. So I will say Pythagorean theorem is a squared plus b squared equals c squared. So here this would be 6 squared plus 6 squared equals c squared. So 6 squared is 36 plus 36 equals c squared. So 72 equals c squared. And I'm now going to take the square root then to solve for c. But what I want to do here, because I know I want to find the pattern, is I'm going to break down this radical. So I'm going to break 72 down into 36 and 2. And the square root of 36 is 6. So I get here, c is equal to 6 square roots of 2. And again, I'm going to leave it in radical form because that's the form that we're going to be leaving our answers in for this lesson, but it's also going to show us the pattern. So this here is going to be 6 square roots of 2. So now let's take a look at the second example. Now I know the hypotenuse and a leg, but I don't know the other leg, A. And again, in that first example, we know both legs, but we didn't know the hypotenuse. Okay, so here, this is going to look like A squared plus B squared, which is 2. 2 squared equals 2 square roots of 2, all squared. So a squared stays the same, 2 squared turns into a 4, and 2 squared to 2, again I have to distribute that squared to both terms. So 2 squared, this one squared, is 4. 4 times the square root of 2 squared is just the number under the radical, just 2, because the square root and the squared symbol cancel out. So I end up getting a squared plus 4 equals 8. subtract 4, and get a squared is equal to 4. Take the square root, so a is equal to 2. Just wanted to change colors there. So here I'm going to write a equals 2. Okay, so let's back up. In the first triangle, we had 6 for a leg and 6 for the other leg. Those were the same, and they were legs of a 45, 45, 90-degree triangle. And so if you have the same angles, right, 45 degrees and 45 degrees, they're going to have the same corresponding side lengths because they're matching angles, and the sides correspond with their angle measures. And then the hypotenuse was whatever the number of the leg was times the square root of 2. Now let's look at the triangle 2 that we just completed. Both of the legs were the same, they were both 2, and the hypotenuse was the same number as the leg times the square root of 2. Are you starting to see a pattern? Well, let's look at the third example just to make sure. Well, on the third example, we're only given the hypotenuse and neither of the legs. But usually you need two sides to solve, at least two sides of a right triangle to find the third if you're using the Pythagorean theorem. But have you already noticed the pattern? Well, I did too, and I do hope you did. So if we're given 8 square roots of 2, the first number in front is just going to be whatever the legs are. So 8 and 8 would be the 2 legs, and I could prove that using the Pythagorean theorem. But as you noticed before in the other 2 examples, you do see a pattern, right? The numbers for the legs are the same number in front of the square root 2 of the hypotenuse. So what was the pattern? Can you fill in what the side lengths of a 45, 45, 90-degree triangle would be with using the variable x? So the pattern was that the legs are congruent or the same, and the length of the hypotenuse is the length of the leg times square root of 2, as you can see at the picture on the left. Now let's take a look at another special triangle, the 30, 60, 90 triangle. Using the Pythagorean theorem, find the missing length. So here you could see that they're either 30 or 60 degrees, the angles, and 90 degrees, and then there are corresponding sides. So let's take a look at the first example and use the Pythagorean theorem. So I know here a leg and hypotenuse, right here, this example. And so what I'm going to do is I'm going to say here a squared plus b squared equals c squared. And 4 squared is 16 plus b squared equals 64. Subtract 16, and I get b squared equals 64 minus 16 is 48. Now, again, we are not going to just take the square root of 48 and leave our answer as a decimal. Let's break this down, break the square root down. So I'm going to take the square root of both sides, and a square root that goes into 48, the largest perfect square would be 16 and 3. Square root of 16 is 4. So here, b would equal 4 square roots of 3. So if I go back up, I can write where b is, and I can write b equals 4 square roots of 3. Now let's look at the second example. Here I have given another leg and a hypotenuse, the long leg. The other example I was given the short leg, right? Because this side is shorter than this leg, and I also know that because 30 degrees is across from it, and 30 is a smaller angle, so it should go with the smaller side. 60 is the larger angle, so it should go with the longer side. But let's look at example 2. I have a squared plus 6 square roots of 3 squared equals 12 squared. So a squared plus square root of 6 to give me 36. And then square root of 3 squared is just 3. So 36 times 3 is 108 equals 144. And now I'll subtract 108. 144 minus 108 is 36. Square root of 36 is 6. So here a would equal 6. So let's step back and let's look at these patterns. In the first triangle, we were given of the 30, 60, 90, the short leg being 4, the long leg 4 square roots of 3, and the hypotenuse 8. Okay, so the legs had somewhat of a similarity. They both had 4s. And then the longer leg had square root of 3, and the hypotenuse was double the short leg. Okay, let's look at the next example. Short leg is 6. Long leg is 6 square roots of 3, so the same number for the long leg, but added with the square root of 3, and the hypotenuse is 12, so double the short leg. I'm starting to see a pattern. Are you? Let's see if we can fill in triangle 3 without having to do any of the Pythagorean theorem. So the short leg is 5, long leg is 5 square roots of 3. What do you think the hypotenuse is? You got it, it's 10, double the short leg. So here we've gone through a couple examples of 30, 60, 90 triangles. What was the pattern? Try to draw in using the variable x with what the pattern was for each side length. The length of the hypotenuse is 2 times 2x, the length of the shorter leg. The length of the longer leg is square root 3 times the length of the shorter leg. We can call the shorter leg here x. So again, the shorter leg is x, longer leg is x times square root of 3, hypotenuse is 2x. Here again is in words and another drawing of the key concepts that we just figured out from the 45, 45, 90 degree triangle and the 30, 60, 90 degree triangle. Now let's go through a couple examples of using that pattern that we just figured out. So let's look at example 1. Now let's remind ourselves what the example is for the short leg, the long leg, and the hypotenuse given x. So again, I just put a little bit of a reminder right here so that we can reference when we go through these 30, 60, 90 triangles. So given the hypotenuse here, which is 16, that's really 2 times the short leg. So let's go backwards. And 16 is really 2 times 8, which would be x here, the short leg. Then the long leg would be 8 times the square root of 3. And that would be our answers. So now let's look at example given the short leg. So we are given here 7 square roots of 3. So the short leg really is just x. So, what are we going to have to do now to get to the long leg, which is really x times square root of 3? Well, we need to take our short leg here and multiply it by square root of 3. So I'll say 7 times the square root of 3 times the square root of 3. And square root of 3 times square root of 3 is square root of 9, which is just 3. So 7 times 3 is really 21. So here the long leg is 21. And the hypotenuse is 2 times the short leg. So 2 times 7 square roots of 3. So again, with radicals, you're allowed to multiply the numbers that are outside the radicals together, which would be the 2 and the 7, which would be 14 square roots of 3. So this would be 14 square roots of 3 here. So sometimes the numbers that you're given for sides seem like they should actually be with another side, but really they're just trying to, with the examples given, make sure that you know how to go from one side to another side. Now let's take a look here at given a long leg. So we are given the long leg of x square root of 3, and let's get to the short leg here, which would really just be x, and that's what it's called, x. So if we're given 8 square roots of 2, and we need to get to just x, what we have to do is we have to divide by square root 3 to get the short leg. So again, we want to get from here to here, and so we just want x. So we're going to divide by square root 3. But when we divide by square root 3, now we have a radical in the denominator, and we can't have that. So we have to multiply by what's in the denominator. So again, our radical rules don't go away. And 8 square roots of 2 times square root of 3 is 8 square roots of 6. Square root of 3 times square root of 3 is square root of 9, which is just 3. So really my short leg here is 8 square roots of 6 all over 3, and I can't simplify it anymore. So that would be done. Then to get to the long leg, the hypotenuse, I need to take my x and multiply it by 2. So that's 8 square roots of 6 all over 3 times 2. I can multiply the 8 and the 2 together because the 2 is not under a radical, and get 16 square roots of 6 all over 3. So as you can see, there's a lot to do to get from one side to the next, but you just have to follow the rules that you're given for these special triangles. All right, now let's go through 45, 45, 90 degree triangles. So here, again, our legs are going to be x, and our hypotenuse is going to be x times the square root of 2. Let's write that down so we remember that. So if I'm given one leg of 6, I know the other leg will be 6 here, and then the hypotenuse is 6 times the square root of 2. Very simple. And that's if you know a leg. Now let's look at if we know the hypotenuse. So I know 10, so I'm at x times square root of 2, and I want to just get to x. So I need to divide by square root of 2, and I'll write that over at the side. Divide by square root 2 to find leg, or which is just called x. So I'll take 10 and divide it by square root of 2, but that's breaking a rule because we can't leave a square root in the denominator. So we'll multiply by square root of 2 and get 10 square roots of 2 all over 2. Divide by 2, and the 10 turns to a 5, square roots of 2. So if that's one of the legs, the other leg is just the same, because again, the legs are the same in a 45, 45, 90 degree triangle. So 45, 45, 90 degree triangles are a little bit easier to solve than 30, 60, 90. Thanks for listening. Please check Schoology for more information. Have a great day.